Alright, so this is a short video explaining how to solve problem 110 in chapter 3, Chem 101, Zumdahl, atoms first. So the confusion with this problem, what confused me at first, is it wasn't clear that they were saying that you started with 4 grams of this compound M2S3. You don't know what M is, it's an unknown metal. And you make the metal oxide. And it said that this compound weighed lost 0.277 grams. Well, what they're saying was that the amount of the metal oxide that's formed is 4 minus the 0.277, or 3.723 grams. Once you realize that, then it's pretty straightforward. Okay, so the other thing is, because, see this subscript here, there's 2 M's in one formula unit of this compound here. And there's 1 M in here, so that means for every one of these that oxidizes, that forms the oxide, you have to make 2 of these. So 1 mole of M2S3 makes 2 moles of MO2. So we can say that, okay, let's do it this way. Moles, N stands for moles. So the number of moles of M2S3 that we have, multiply it by 2, that will be the moles of the MO2 that we make. Well, we can say this. Moles of anything is equal to the mass in grams of that substance divided by the molar mass, that's capital M, in grams per mole. So all we're going to do to solve this problem is, okay, because we know the mass of M2S3 now and the mass of the MO2, we're going to substitute those for the little m and write out what the molar mass would be. So let's do it this way. Okay, so the mass of the M2S3 is 4.000 grams. I'm not going to put units so that it looks cleaner here. The molar mass would be 2 times the molar mass of M, which I'll call X, plus the molar mass, plus 3 times the molar mass of sulfur, which ends up being 96.198 grams per mole. So just so that you understand what this is 4.000 is how many grams of M2S3 we had. X is the molar mass of the unknown metal M, okay? And there are 3 sulfurs in one formula unit of M2S3. 3 times 32.066. That's the molar mass of sulfur. That's where we got the 96.198. This is going to be grams per mole, but I'm not writing units. So we said that so this expression right here gives us moles of M2S3. We're going to make twice that many moles of MO2. So if we multiply by that 2, that'll be equal to the moles of MO2. Well, moles of MO2 is just a mass, 3.723 grams, divided by the molar mass of M, which we're calling X, plus 2 times the molar mass of oxygen, 2 times 15.999, which is 31.998 grams per mole. Now we have an expression with one unknown. We can solve it. X will be the molar mass of our unknown, or the average atomic mass, same thing. So let's do it on this page right here. So if we multiply through by 2 and cross multiply, we get Okay, so 8.00x, I multiplied the 2 times the 4, cross multiplied. Okay, 8 times x plus 8 times 31.998. 8 times 31.998 is 255.984. Cross multiplying here, 2x times 3.723 gives us 7.446x plus 96.198 times 3.723 ends up being 358.145. Collecting like terms, going to subtract 7.446x from both sides. Left with 0.554. Erase some of this stuff. So now, just coming back up here, subtracting, I guess do it down here, minus 255.984 on both sides. And I'll write the result up here. We get 0.554x is equal to 102.16. Dividing both sides by 0.554, we find that x is equal to 184.4, and it's going to be grams per mole, or AMUs for the average atomic mass. And I think that ends up being closest to tungsten.